Okay guys, here we are. I don't know if you've ever seen a 4,000 amp breaker before, but there it is. Okay? This is a gear I put in 2005. It's so nice to be able to come back and get a call from a job that you did so long ago. So we're gonna power this off once we get permission, and we're going to repair this Prologic meter. So I'll show you in a second how to shut this off. Okay guys, so what I do, we're going to be shutting down this gear. We can't do a hot swap on the Prologic meter because the toroidal coils on the current sensors are too powerful, because this is a low voltage, high current system. This is a 240 volt delta, 4,000 amps. So the power that comes off the current transformer exceeds something you wouldn't do live. So before I'm going to power off the main breaker, I'm going to shut off all the individual loads. So if we get approval from the customer, we're good? Good. Okay, so customer says we're good. And what we're going to do is we're going to shut off all the loads before we shut the main off. So now we're going to shut off the main. Let me show you how I shut off the main. I'm going to bring you over. So this main is a newer main. Again, I put this in 2005, and this has a spring actuated. So it's already ready to open. It's energized to open. So if I press push to open, it's going to just make a loud noise and it's going to open up, which I'm going to do right now. 3, 2, 1. Okay, now you can see it opened up, you can hear it, and it also gives me this indication that it's open. Now it also shows I can't re-energize it without cranking up and putting back the spring pressure, but we'll do that after the job is done. All right guys, so I was here the other day on Monday trying to do this hot, and here's the meter. I had already removed the meter, and here are the donuts, and the amount of power that was rushing through this. And here's my toroidal coils right here. So these determine how much current is coming through, so the customer knows what the load is, right? And that way you can compare that with the utility company. So because this is low voltage, 240 volt at 4,000 amps, the magnetic field emitted by these donuts was incredible. So I'm going to get the model number off of that. And that way I can see which one it is. So we have one. Now the center phase doesn't have a donut. I don't have a technical answer for that, but it just doesn't. So it's got phase A, and phase C has the donut. You can see there's the wires going to it. They come across here. Now I wish these had a DC shutoff, but they don't, because if they did, I would have been able to do this live. So let's continue. Now I don't smell the ozone. Now when I did this on Monday while this was hot, I could smell the ozone. That's how much current was coming off of this. So we're looking good. Okay guys, so it's not real exciting with it off. However, when this was on, I couldn't even bring my meter. A high voltage arc would come from this terminal about a ½ inch away, and that's when I stopped at that point. So you could see how much the magnetic field comes through, because this is a passive device. It's just wrapped around. So the magnetic field from the incoming power is exciting the magnetic field around that toroidal coil, which is giving the reading, and that output can be really high. So it's very dangerous, and be careful. We're going to measure from phase to phase on this system. Okay, and we're off, which is good. Perfect. Okay. Yeah. let's talk about the display now. Real quick, we gotta get this on. The old display. Back on. First thing we want to do is check all our connections. Okay, which we did. We have our 2 coils and our voltage in and our display out. This is our system down. So this is how we're going to re-energize. So we need to bring back spring pressure. So all the load breakers are off. So what I'm going to do now is I'm going to pump up this handle until this turns yellow. Okay, see how it said okay? Now I'm ready to energize. So as push to open, we're going to push to close. So 3, 2, 1, and we're on.